Hi guys, today we will be doing lesson 5, phase transitions. Be sure to watch the Science Max video that I have up there, and you can do the experiment if you want to with the cornstarch mud. Also, be sure you make some time to print and assemble the mini book, Phase Changes of Matter. And once you have that done and you would like to read it with me, there is a video and it's optional. If you want to read the book with me, I will read it with you. And print out types of phase transitions for your science wall. We will also need this for class on Thursday. I want to make sure we're going to go over these types of phase transitions together and do a little activity. There are 2 experiments that we're doing today, and one of them is the freezing point of water, and the other one is expansion of water. So I want you to print the instructions out, and we're going to go through both experiments in this video. For the 2 experiments that we will be doing, you will need these supplies: 4 paper cups, a permanent marker, salt, water, 1 teaspoon measuring spoon, 1 cup liquid measuring cup, or a 250 milliliter graduated cylinder if you're fancy, a candy thermometer, a straw, a cup of water, Play-Doh, a short glass cup or jar, and food coloring, optional. So make sure you have those things and then move on. As we learned in the previous lesson, the 3 classic states of matter are solids, liquids, and gases. Solids, liquids, and gases are comprised of matter, and the tiny particles that make up these 3 states of matter are called molecules. These molecules are in constant motion, but they will move faster in a gas state than in a liquid state, and faster in a liquid state than in a solid state. In this lesson, we are going to learn how matter can change phases. When matter changes from one state to another, we call this transition a phase, or a state change of matter. So here are the types of phase transitions. From a gas to a solid is called deposition. From a solid to a gas is called sublimation. From a gas to a liquid is condensation. From a liquid to a gas, it's vaporization. From a liquid to a solid, it's freezing. From a solid to a liquid, it's melting. So in class, when we have class on Thursday, we are going to go over all of these phase transitions. There are a few videos that I posted online on the website under lesson 5 that shows you deposition in action, sublimation and deposition in action, and sublimation in action. They're short videos. So what I want you to do in the meantime is watch those videos on the phase transitions and think about the different substances that change from a gas to a solid, or a solid to a gas to a liquid, or a liquid to a gas, or a solid to a liquid, or a liquid to a solid. For the rest of this lesson, we will be working on the experiments. There are 2 experiments that we're going to be doing today. Now, before I get into the experiments, what I wanted to do is share something that in lesson 3 I didn't share with you, but it is relevant for what we are doing right now because we are measuring water. So having accurate measuring tools is very important, but it is more important to have correct measuring habits. One of these habits is reading the volume of water at the bottom of the meniscus. So this is a meniscus. If when you pour the water into the graduated cylinder, if that's what you're using, or if you're using a measuring cup, you might notice that the water will not be straight across and flat. It will be curved. This is a concave meniscus. And when you, like right here, when you are measuring and you find that your measurement is concave, well, you are going to read at the bottom of that arc, at the bottom of that water level right here. You see that? So this is the accurate measurement of water, is right here. Now, if your meniscus is convex, then you are going to measure at the top of your level. So different elements or different substances have a different way of reacting with their physical environment. Now, water apparently has a concave meniscus where you would be measuring at the bottom of the concave water level, and mercury has the properties in reacting with the physical environment of their container will have a convex meniscus where you would record the measurement at the top of the level there. So another important thing is when you are measuring water, or you're measuring a substance, liquid substance, you're going to place it on the table or a counter, and you want to look at the level at eye level. So you want to be able to look at the side while it's sitting on a flat surface. You want to look at the side of it so you can make sure to get an accurate measurement. So let's read through this first experiment. Lesson 5, the freezing point of water experiment. Information. In this experiment, we will discover the effect on the freezing point of water when salt is mixed into it. Pure water can freeze at 0 degrees Celsius, which is 32 degrees Fahrenheit. When salt is mixed into the water, this affects its freezing temperature because it is no longer just water. Hypothesis. To hypothesize means to make an educated guess. Take a guess based on information provided above. How do you think salt will affect water when we freeze it? Which do you think will freeze faster, pure water or salt water? Which will require a lower temperature to freeze, pure water or salt water? So now what I want you to do is fill in this area here with what you hypothesize. What is your educated guess on these questions? And if you need to rewind or you need to reread parts of this, go right ahead. And then when you are done, I want you to complete the rest of this lesson video. The freezing point of water experiment instructions. I want you to get out your instructions, which I think are 2 pages, might be 1 page. Gather the needed supplies: 4 paper cups, water, salt, a measuring spoon, and a 250 milliliter graduated cylinder, or a liquid measuring cup. Read through each step before starting. You will also need a thermometer. If you are measuring liquids, be sure to read the measurement at eye level, at the bottom of a concave meniscus, and at the top of a convex meniscus. If the meniscus is flat, you will just read the measurement of the water line. 1. Begin by properly labeling your cups. Label each cup with one of the following labels. You're going to have one that says water. You're going to have one that says water plus 1 teaspoon salt. You're going to have another one that says water plus 2 teaspoons of salt. And then you're going to have another one that says water plus 3 teaspoons of salt. You should have 4 cups. Measure 1 teaspoon of salt and place it in the corresponding cup. Do this with 2 teaspoons of salt and 3 teaspoons of salt, placing each measurement in their correct cups. Then measure out 1 cup or 250 milliliters of warm water for each cup. Try your best to keep the temperature of the water consistent for each cup. The cup with just water is the control of the experiment. Having a control group ensures there are no other factors aside from salt affecting the freezing process. 3. Stir each cup until the salt is dissolved, beginning with the least salty to the most salty. This is a good lab technique to ensure you are not introducing more salt into the cups with the lesser amounts of salt. To dissolve means to mix a solid into a liquid so that it becomes a part of that liquid. Note, dissolving a solid into a liquid is not a phase change, and the concept of dissolving will be discussed in greater detail in a later lesson. 4. Measure and record. Once the salt has dissolved into the water, measure the temperature of the water in each cup. Remember to practice good lab techniques by rinsing the thermometer after each measurement, or go in order from no salt to the greater amount of salt. Record each measurement of temperature on the first row of the data recordings section on your Lesson 5 lab notebook page. Tip: when observing and recording temperature, record the temperature when the red liquid inside a glass thermometer stops moving, or if you're using a digital thermometer, when the numbers stop moving. Place the thermometer in the center of your liquid, not too close to the surface, the bottom, or sides of the cup.